So I started recording, guys. Just once again, we'll go to the previous part. So just to make you habituated to study the what previously happened. So we discussed about a networking. Okay, what is network? What is networking? What is internet and intranet? Okay, and LAN, MAN, CAN, WAN, local area network, wide area network, metropolitan area network, campus area network. Okay, and also we discussed about minimum requirements to create a network. It's like a NIC is required for any device to connect a network. NIC is required. Media is required. Cables, like kind of stuff is required. And next one is protocols and logical addressing. So in that one, we discussed about NIC, network interface card, also called as a local area network card, LAN card, Ethernet card. In Ethernet card, we have a different type of Ethernets are there. Ethernet, fast Ethernet, gigabit Ethernet. And also we discussed about cables, fiber optical cable, coaxial cable, mainly UTP, STP cables. Unshielded twisted pair cable, shielded twisted pair cable. Okay, so it is contains 8 wires. We call it as a 4-pair cable. Each pair of the wire is twisted each other. Okay, and different category of the cables are there. The connector we use here, it is RJ45 type connector. Each NIC having a MAC address. The MAC address given by manufacturer of NIC only. Okay, it is 48-bit in a binary, 12 hexadecimal. To check the MAC address, get MAC is a command, or you can use IP config space /all. Okay, and next what we discuss, of course, normally GI mode also you can see the MAC address. So go to run ncpa.cpl on your network adapter, right click, status, details. So you can see your physical address. MAC address is also called as a physical address. Next we discussed about a protocols, but I put a protocols into your OSI layers, of course. Topologies also we discuss: bus topology, ring topology, mesh topology, star topology, other topology like a point-to-point, multi-point, hybrid topology kind of stuff is there. So bus topology is having a one backbone wire. Okay, there is a wire. So device is connected to that backbone wire only. It is very easy to configure. But problem is if wire is disconnected in a different any particular location, so continuous communication will be stopped. Okay, so and next one is ring topology. Every device is connected to next device. Like that, we will connect one device to another device, other device to other device, like that. And last device is connected to first device, and we form a ring. We form a ring. Okay, so that is a ring topologies. Mesh topology. Every device is connected to all other devices. Every device is connected to all other devices. That is a mesh topologies. It is a highly redundant, complex, more wires, more connections are required, but it is redundancy wise, it is be useful. Okay, but we are using in general network is star topology only. So we connect devices to a centralized device, that is a hub or a switch. Okay, so every entire communication go through the centralized device only. We can connect easily one switch to another switch to create a big large LAN network. Big large LAN network we can able to create it. So easily scalable. Redundancy wise no, because centralized device is down, entire network is down. Okay, so like that. Okay, so this is the physical topologies, point to point. So connecting one device to another device, router to router, PC to PC, like that, point to point communication. Okay. Yeah, devices, hub, switch, router, modem. These are all devices we use in the network communication. Hub is used to create a simple LAN network. It is suitable for a small size networks only because it's broadcast every packet to all the systems. Okay, irrespective of who is sending, who is receiving, we send to everyone. So that is a hub. Hub act like a repeater, also like a repeater. Next, switches. What is switch? Switch is also used to create a simple LAN network, star topology network. A little intelligent, so it can understand MAC address. It create a MAC address table. It create MAC address table. Okay, by mapping of MAC address of a system to port number of switch. Port number of switch. So then obviously entire communication is like this. So once MAC address table is created, switch start doing unicasting, means PC send a messages like a one PC, A PC want to send a packet to B PC. So switch, when we start a switch, that time it works like a broadcast, like a hub only. But later, when it is created a MAC address table, it will forward the packet to the BPC directly. So without broadcasting it, because it know where the PC is connected. Next is the router. The router is used to connect your LAN network to WAN network. Normally, router is used to connect your LAN network to WAN network, and also we use WAN. In a WAN network, we use routers, not switches. We use routers. Router is basically 2 points are there. Router is also understand IP address, IP network, IP address, IP network, and also it will show the best path to reach the destination. It will forward your packet. So then like that we can able to reach the destination. It will forward your packet to the next router. So like that we reach the destination. Best path selection. Okay. So it use routing protocols like RIP, EIGRP, OSPF, BGP, ISIS. Okay. These are all we discussed. Finally, yesterday we discussed OSI layers. Okay. OSI, Open System Interconnect. It is a reference model, so we don't use it directly to communicate. We use it for understanding of network and troubleshooting of network. OSI layers are very useful. It is a 7-layer model. 7 layers are there. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Okay, application layer will take care of application part of communication, meaning is server side, client side applications, server side applications like a web server, web browser. Okay, also application layer understand what type of service you want to access, like protocols, port numbers wise. Application layer will decide what type of communication you want to do it. Okay, like a HTTP, HTTPS, FTP, SSH, Telnet, SMTP, POP3, IMAP, okay, DHCP, DNS, RDP, Kerberos, LDAP, NTP, NNTP, TFTP, SNMP. These are a different type of network protocols to communicate in the network. So based on the protocol, that is what type of communication it is, like your mail communication or a web related communication or file transfer related communication, remote access related kind of communication. We can understand by protocols only. Presentation layer. The presentation layer belongs to presentation layer. Compress your data, decompress your data, encode your data, decode data. It converts your data into ASCII format. And it encrypt your data and decrypt your data. Session layer. The session layer is establish a session, maintain the session, and terminate the session. Means whenever you start communicating from your client to server, automatically session will be created. So once communication is completed, the session will be ended. The session layer will maintain the session till the total completion of thing. You know, if you open a Gmail, so I open gmail.com, my mails are open, so like this. This for observation purpose I am telling. Just I open my Gmail window. Okay, so if you observe after a few seconds or a few minutes, you can see after some time, it reloads the page. It reload the page. So every 15 second, 20 second. It means when I send a request, based on my request, my session, it is open already. It will be open. Once it is open, session completed. And it will reloads. Again it will reload. The page will be reload. Not reloading not like this. Not this kind of reload. I'm not talking about this kind of reload. That is application wise. But the entire your Gmail, it is try to reload and get back. So 1 second, guys. Okay. It is a session layer. Now what is another layers? Transport layer. What transport layer will do? What transport layer will do? It segment the data. One second, guys, please hold. Okay. Transport layer is a it segment the data. It put a no. So don't put a nodes. Just we'll keep it here only. Work is completed. Okay. Transport layer, what it will do? It segment the data. It cut the data into small parts and it put numbers, sequencing orders in it. Transport layer also do like a error correction because of if you loss of data, I can send the data again. A packet is corrupted, so I will send the packet again because of TCP IP part. Okay, error correction means that one, not error detection. Transport layer also will do error correction because of one part of packet is missing, one part is missing, so I am sending again, so then we can rearrange it properly. That is called a error correction. A transport layer provides end-to-end connectivity out of OSI layer. It segments the data. It put a numbers on it and sequencing order, error correction, and it divide a TCP UDP port numbers into TCP and UDP encapsulation or a multiplexing which will do. Okay, so that is and also flow control by transport layer. Flow control also one of the duty of transport layer. Okay. What last one? So what you can tell? Yeah, TCP UDP differences. Transmission control protocol, user datagram protocol. That is TCP UDP. So transmission control protocol, TCP protocol is acknowledgement based communication. UDP no acknowledgement based. So TCP type protocols use acknowledgement like when you send a packet, when destination received a packet, destination send back an acknowledgement to you. Okay, so if you receive a acknowledgement from the destination, meaning is packet delivered successful. Your packet is delivered successful. Okay, in case of packet is corrupted or dropped or something is happened, you didn't receive a acknowledgement, means packet is not delivered properly. So then you have to resend the packet. That is TCP. In UDP, we send a packet, we don't know whether destination PC received or not. So that is TCP UDP. Reliable, non-reliable, connection oriented, connectionless. Connection oriented and connectionless. Network layer. What is a network layer? May I said this one already or what? The router. Right, so network layer dealing with your mind is not at all working. On intention. Okay, network layer is network routed protocols and routing protocols like dealing with IP addresses. Okay, IPv4 or IPv6, different type of IP address. Sorry, IP addresses it will deal. Addressing part, logical addressing part, it will deal. Routing protocols. Routing protocols means RIP, EIGRP, OSPF. So routing protocols will tell you how to reach the destination. Okay. Next one is this in a network layer. So source IP address, destination IP address will add it to your PDU. So that is called a packet. Transport layer, TCP header will add it to your PDU. Then it is called as a segment. The source IP address, destination IP address is added to your segment, then it is become packet. The packet is forward to data link layer. In data link layer, so we have two layers. One is LLC, another is a MAC. So LLC is a logical link control, MAC is a media access control. Okay, logical link control is actually take care of your WAN protocols like a PPP, SDLC, frame relay, okay, MPLS, like these are all WAN protocols. And the data link layer, we have a MAC layer. MAC layer take care of MAC address, physical part layer kind of stuff like a MAC layer. MAC address, media access control, 48-bit, 12 hexadecimal. So your data link layer will add a source MAC address, destination MAC address to your packet. That's why, last when I told about switch, that time I explained. In a packet, when you are sending a packet, the packet contains totally 4 addresses: source MAC address, destination MAC address, source IP address, destination IP address. Okay, so that is your total packet. plus data, of course. And data link layer also add CRC as a data tail. Okay, CRC as a data tail. So CRC for detect errors. So data link layer, error detection, transport layer, error correction. Got it? Transport layer, error correction, data link layer, error detection. In following layer, which layer having a error detection? Okay. So physical layer, data link layer, transport layer, presentation layer. Obviously data link layer like that. Okay. So transport layer, error correction, data link layer, error detection. So CRC will detect any error is there. If any error, if possibly try to repair it, otherwise it drop the packet. Okay. In data link layer only, we know when you are transmitting a data, so error data can be corrupted. So if data is corrupted, packet drop. Okay, so that is data link layer. Next, the data link layer add source MAC address, destination MAC address as a header, data header to the packet, and CRC as a data tail to the packet. So the total package is, what is the total one? Frame. The frame is go to physical layer. The physical layer convert the frame into bit stream. Bit stream is converted into electrical signal in the form of, if you are connected to normal electrical, means wired connection kind of stuff. If it is a wireless, like a Wi-Fi type of connection, radio waves. If you are connected to a fiber optical channel kind of connection, it is a light waves. So this is a totally OSI layers. So up to here we discussed it. So how much time it is taken, guys? When I started telling, almost like half an hour. Hmm?
Yes, sir.
So how much time you need to study? Just you revise daily. You won't not required more than 1 hour also. Okay. Like small part is very easy, right? So instead of preparing 1 month course in one night, because everything is important here. Okay. So that's what I'm trying to say you guys. So how to prepare for interview? So then you guys will ask only two things. One is like a questions. Sir, tell me what are the questions they will ask. Yeah, it is a very good one, of course, but still don't go with only question, guys. In our interviews, there's no like only these questions only will ask. You don't ask any other questions. They didn't sell that right now. That is interviewer ways to ask any question. You have to be ready to tell an answer properly. So the answer is very important. Interview questions are secondary. Okay, question, whatever the question is, but you have to tell an answer. That is very important. Within the syllabus, out of the syllabus, nothing is like that. Okay, we should be open-minded. So how to become that one? Just study, practice, reading it, searching it. We have to explore ourselves. Okay, so in a OSI layer only, so there is a few more points are there. So I will tell the OSI layer few more points. Then we'll go to the next part. Again, application layer, presentation layer. Why I'm telling so many times? Compulsory you have to present. So by repeated reading, repeated writing, repeated speaking, you can able to remember. because you know I took a training. Means we went to the CCNA courses. Okay, in engineering we have a OSA syllabus, this networking related thing in electronics and communication engineering. Okay, so we have a syllabus. Subject is there, but I went to CCNA training also. Wherever I go in interview, these are the common question. So what we do? We keep reading, keep reading, keep reading. Then only we implement it. Application layer, presentation layer, session layer, transport layer, network layer, link layer, physical layers. There's a few things compulsory we keep it in mind only. So these are the 7 layers, okay, of OSI. So this is your layer. One is physical layer. We call these layers, last 2 layers are last 3 layers are hardware layers, right? So hardware means there is a devices are there also, right? So hardware layer, hub is a layer 1 device, switch the layer 2 device, router is a layer 3 device. Okay. So devices, router, switch, hub, examples of layers. So that's why I written when I tell a hub, it is a layer 1 device, means it belongs to physical layer. Only it is physical layer property, like a basic properties only. Don't understand any MAC address kind of stuff. But data link layer belongs to MAC address. Switch understand MAC address. Network layer understand routed protocol and routing protocol. So router can understand IP address and as well as a routing protocols. So like that, so we can say this is a example. Hub is a layer 1 device, switch is a layer 2 device, and router is a layer 3 device. And a switch, some people ask, so sir, what is layer 3 switch means? Okay, what is layer 3 switch? So layer 2 means only MAC address. Not regular switches are layer 2 switches only. But layer 3 switch is, we use it for a certain switching purposes. So mainly like a switch and router. Act like a switch and a router. Regular router, LAN ports are limited. Our router is used for WAN communication. Okay, so LAN ports are limited. Okay, LAN ports are limited. Switch, anyway, it is used for a LAN communication. More LAN ports are there. Not unlimited. So large, okay, large number of you can say the number of LAN ports or more. Like a example, 24 port, 48, 24 port switch, 48 port switch, 72 port switch, also there. 16 port, 8 port, 4 port also there. It is a switch. So smaller number of ports are there, large number of ports also there. So that is a switch. So you want a switch related properties with the WAN protocols, you can able to run it. So then we use layer 3 switches. We use layer 3 switches. Okay. Of course, the switch contains some other histories also there. That is like a VLAN, BTP, Inter-VLAN, routing. So these concepts are there. So for this concept, we use layer 3 switch. Okay. L3 switches used for inter VLAN routing. Okay. So this is the I just put a information, but next we'll see what is inter VLAN routing kind of stuff. What is a OSI layer? There is a 3 layers are there. So Datalink, hub switch router, and there is a layer 3 switch is also there, which acts like a both switching and routing. Regular switch having more LAN numbers, more LAN ports are there, and regular router LAN ports are limited, means two ports, 4 ports, like that. Only very limited LAN ports are there. Okay, for LAN connectivity, very limited port numbers, or 8 port maximum, not more than that one. Okay, so if you buy a Wi-Fi also, so we'll get a very limited. Okay, so that is normal regular router. Router means Cisco router kind of stuff. So very limited LAN ports. But if you take a switch, big LAN ports. So you want a LAN communication, VLAN communication, and inter-VLAN routing. So for implementing inter-VLAN routing, we use layer 3 switches, because routing concept you have to implement. So then we can do it with the layer 3 switches only. Only router can do that kind of stuff. So that is logical communication and all. We'll see that one. Once. So what are I want to see? Yeah. So look at here, guys. Already you have done this one. So application layer, presentation layer, session layer, and transport. So in a application layer, so take care of protocols. Okay. What are the protocol, port number, what is service? Things. Presentation layer, encode, compress, encrypt. Session layer, anyway, start session, get a session ID, right? Transport layer, segmenting, what it will do, number, sequence, windowing, TCP kind of stuff. This is source IP I will add it, destination IP will be added, routing protocols are added. This is source MAC address, destination MAC address, ERC, physical layer. The frame convert into, it is a bit string. and it is converted into some signal, electrical signal, light signal, whatever it is. Now, as I said, you can remember you can take this one in a reverse order also, right? So physical layer, it means this is one PC, send a complete signal, and other side we are receiving it. On the other side we are receiving it. Physical to physical connectivity is there, na? So like the other side we received a signal, electrical signal or mechanical signal, whatever it is. So we received a bit stream. We assemble the bit stream. Okay, we assemble the bit stream and make it as a frame. The frame is going to forward to the data link layer. Frame is given to data link layer. In data link layer, it verify source MAC address, destination MAC address, and CRC. First, it will verify with the CRC. Is a packet is safe or not, corrupted or not. So it detects data is corrupted or not. CRC, using CRC. Next, it will check the source MAC address and destination MAC address. Okay, so it understand this is my MAC address. This is destination MAC address is belongs to me. It will accept the packet. If destination MAC address is not belongs to that PC, it drop the packet. It drop the packet. So destination MAC address, either this PC, the second PC, destination PC's MAC address or a broadcast ID, not a different one. If you bind it, means compulsory MAC address matches for security reasons. So it will check the MAC address matches, accept the packet, not matches, don't accept the package. Next one is network layer. Next one is network layer. So what it is, a network layer will check it, source IP it will check it, destination IP address, verify. So when data link layer done with the MAC addresses and CRC, it remove the MAC addresses from there. Okay, and the packet, it remove these things means remaining is packet only. The packet is forward to the network layer. The packet contains source IP, destination IP. Again, destination verify. Destination is verify this destination IP address belongs to me or not. If system check like a destination IP address matches, it accept the packet. Otherwise, it drop the packet. It accept the packet. Otherwise, it drop the packet. Source IP and source MAC address. There's a source IP and source MAC address. It create a ARP table. So whenever it is received IP address and MAC address, we create a ARP table. There they put it IP address and MAC address of the remote PC. Okay, that is the network layer. So network layer, check the IP address, confirm the IP address, and remove the IP address part from the PDU. Then remaining is segment. Okay, so it forward that part to transport layer. So what is happening here? These are segments. It check the numbers and put it in a sequence order. Okay, it assemble all other packets and verify the protocols also. Verify protocols also. So that is your transport layer. Session layer, understand session ID, okay, and maintain the session part. So next is presentation layer. You know presentation layer, right? Data is encoded. Now here it is decode. Data is compressed. Okay, it decompress. Data is encrypt. Encrypt. Okay. So next, finally, application layer. So application layer finally received your packet. Application layer finally received your request, understand the request, and start giving reply or a response. Again, application layer, what it will do, it check the what is the type of reply. So what type of reply it is? It's HTTP reply or a DHCP related reply. Okay, so or FTP type of reply. So 2021, right? So depends upon that, receiving a packet and replying to it. So depends upon that, the port numbers are different, protocols are different, or port numbers are different. So what is the response, type of response it is? Because based on that, protocols, port numbers, data will be there. Again, presentation will do encode the data, compress the data, encrypt the data. Okay, so it maintain the session ID. Okay, and it chop the data into small parts and put the numbers and enhance the protocols, everything it will take care. Okay, and make it as a segment. The segment is added with a source IP, destination IP, and that packet is added with the source MAC address, destination MAC address, and CRC. So that frame is the packet become frame. So frame is sent to physical layer. Physical layer use bit stream. The bit stream is converted into signal. The signal is forward to back to our system. Again, same process from bottom to top, top to bottom. That's why I said, guys, either application layer, presentation layer, session layer, transport or network, data link layer, and physical layer. It is to send. At a receiving end, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So that's why it is either top to bottom, bottom to top. Both are okay. You guys understand this thing?
Yes, sir.
Okay.
Yes.
Compulsory physical layer, bit stream, data link layer, frame, network layer, packet, transport layer, segment. So last one, guys, OSI layer and TCP IP protocol suite or a model protocol suite. Anything, any word you can use it. Suite, protocol suite, or a suite, so you can use it. This is originally came from DoD model, not a DDoS kind of stuff, guys. DoD does not mean it is hacking. Okay, it is not a denial of defense kind of stuff. It is a defense. Earlier days, you know, our computers, our network related, when all these things came from the, as we know, from America country only, right? So maximum the starting technologies. The first computer used for launching atomic bomb only, how to launch a missiles or bombs. So that is designed in the computer only. Okay. And next, of course, for rocket launching, also they done rocket launching, NASA related technologies, also computerized earlier. Like that, the network technologies also, networking, communication related, from transmitting data from one place to another place, also in the defense only. Okay. Actually, in India, we take a technologies. First of all, we take a commercial technologies from outside or inside. Later, we implement secure kind of stuff in the research center, like DRDO or ISRO kind of stuff. Okay, so we don't know the products, but you know, in the certain countries, so they researchers like in universities and research labs, private labs are there, and as well as government labs are there, NASA and all things. So they create things for their own purpose. Means only military or a NASA related, means space related or a military related kind of stuff only they will create. So later for a people, public people, so they change it to normal kind of stuff. It's like that. So TCP IP model is built before OSI model and use that one as a DoD model. The name is DoD model. Later name is TCP IP model. Again, the comparison we do it for understanding TCP IP part. So when you are comparing, so if you go to the Google and you will get a lot of other different type of this there, but this is a standard I am telling. Other different names are there, but this is a standard correct one. Application layer, presentation layer, session layer. All these three duties are done in the application layer in the TCP IP. Transport layer is a transport layer. Transport layer is a transport layer. Network layer called as a internet layer. Internet layer, because mainly IP address take care of IP addresses. That's it is called as a internet layer. Transport layer is a transport layer, same duties as a normal OSI layer, transport only. But application layer in a TCP IP has to do application layer duty, presentation layer, session layer duty by application layer only. Data link layer is also called as a network access layer. Okay, so your NIC comes under network access layer. NIC comes under network access layer. So these are the comparison between OSI and TCP IP model. This part I said I will tell now, so that's we will see. But somewhat I told 1 or 2 points here. So the communication in the OSI layer and the difference between TCP and OSI model. Okay. So last point I will tell. So IEEE 802 is standard for OSI layer. Exactly say not a standard for OSI layer, entire your network standard. Look at here. If you use Ethernet 802.3, your Wi-Fi wireless communications 802.11. Okay, you can see that's like you want to buy a Wi-Fi adapter or Wi-Fi router. Immediately, so I want to buy a Wi-Fi router. So you can check it. There is something like a yeah, it is MI4A. Okay. MI also launched routers. You know, the people are fighting and throwing China mobile phones at floor and saying we don't support China and we buy China. But MI launched Maxim electronic goods, right? Then where is the China kind of stuff? Huh? So it's showing some megahertz frequencies, okay? But this is what I'm trying to say. See, it is 802.11, 802.11, 802.11 like this. But what is AC, A, G, N, B? These are different supporting are there, okay? So main standard is wireless 802.11. After 11, it can be A, B, N, G or AC like that. Each one is different bandwidths. Some are support 50 Mbps, 72 Mbps, 128 Mbps, 150 Mbps, 200 Mbps. Okay, like that. So different speeds are there. You can try it. Okay. Normal Ethernet 802.3. 802.3. Okay. Like every device or a protocol or any connectivity has 802 in a starting. It can be a 3 or 5 or a 10 like that it will be there. So this is a 802 standard. What is 802? Okay, it is released at February 1980. So that's why it is given 802. It is a one of the network standard 802.3 and 802.11. Okay, so you can go to this Wikipedia like that also. You can type. So how much bandwidth it will support, what is the frequency. Dual frequencies are there. So 5 gigahertz, 2.4 gigahertz frequency also there. In Wi-Fi standards. Morning only I'm getting headache. But it is okay. But some standards. I think is it enough. Next I will show. We will see IP addressing, guys. Okay. Next class will next part after break we'll see IP address.